Good morning, students. Here we come to discuss the JEE main paper discussion for the 24th of 2026, shift 1 means morning shift. Okay, let's start with the first question. Right. So figure shows a meter bridge. Initially, null point was achieved at a point P as shown in the figure. When the unknown resistance R is connected in parallel with the 3 ohm, the null point was shifted by 22.5 centimeter. Find the value of the unknown resistance phi. So initially they are saying that null point was achieved at point P. Now, here you need to know that if this is 2 and this is L, then that means this is in the ratio of 40:60. All right, because you know that R1 by R2 that is equals to L1 by L2. And this is a meter bridge, so total length is 100. So it is in the ratio of 2:3, that means it is 40 and 60. Now when a resistance R is connected to, this 3 ohm, then overall resistance will be decreases by 3, decreases from 3, so that means this length has to be decreases by how much? So now the new null point will be, you have achieved somewhere at P dash, which will be shifted by 22.5. That means the new R1 by R2 dash is what? It is the equivalent of these two. That will be equals to, now this is 40 plus 22.5 and this becomes 60 minus 22.5. all right. So this is going to be in the ratio of, if I write down 45 by 2, so 80 plus 45 divided by 120 minus 45. Okay, this is 80 plus 45, this is 125 by, this becomes 75. Okay, so this is in the ratio of 5:3. So now R1 is 2 itself and R2 will be 3R by R plus 3. 3R upon R plus 3, as these two are in parallel, which is now is in the ratio of 5:3. So simply solve it, 3 cancel. This is giving me 2 into R plus 3, that is equals to 5R. And this will be 6 is equals to 3R, means R is equals to 2 ohm. So the correct answer is 2 ohm. For this, we go with the option A. Option 1. Move to the next one. A spring of spring constant K equals to 15 is cut into the two parts of the ratio 3:1. Find the spring constant of the spring of the smaller length. Okay, so you know that K is reciprocal to 1 by L. So if I am talking about the original spring, which is let us say of length L, having the spring constant K, which is equals to 15 Newton per meter. Now this spring is cut into two pieces, which is in the ratio of 3:1. That means the bigger piece will be 3/4 of length and the smaller piece of the length L by 4. As you know that K is reciprocal to 1 by L, that means we are talking about the spring constant, this K2. So this K2 will be reciprocal to the length, means this length is decreases by 1 by 4. That means this K2 will be increases by 4 times. So it is 4 times of K, which gives you 60 Newton per meter. Right? Similarly, we can also find out K, but we have to find out this second portion, the smaller one, then the answer is 60. Okay, move to the next one. Fine, this is little calculative. So 3 masses M1 and M2 and M3, okay, they are kept at the vertices of the triangle. So fine, so suppose if in this triangle, if I just assume this length as A and this length as B, what this try to say, this is M1, M2, M3, this is a equilateral triangle, so they are at the vertices of the side 20 meter, and now we want to configure them of the side of 25 centimeters. So if I write down the energy of the system initial, then it will be G into M1, M2 by A plus M2, M3 by A plus M3, M1 by A. right? That is with the minus sign. So this is the initial potential energy. Final potential energy will be what? Minus G M1 M2 plus M2 M3 plus M3 M1. These all pairs are at a distance B. A is my 20 meter, B is my 25 meter. To find out the work done, we can say it is change of potential energy. Whatever work you have done, that will be used as a change of potential energy. So this way we can clearly get this answer, summation of M1, M2 or Mi, Mg, and here you are getting 1 by A minus 1 by B. Okay. Substitute all these values, 6.67 into 10 to the power minus 11. M1, M2, M2, M3, M3, M1, this is 200 into 300, then 300 into 400, then 400 into 200. So it is giving you 6 plus 12 plus 8 and 10 to the power 4. I took it outside. This is 1 by A, that is 1 by 20 minus 1 by 25. These are in meter. Alright, so this is your calculation for this question and just solve it. So finally the answer would come as 10 to the power minus 7 and rest of the term when we solve it, it is coming as 1.735. Okay, so we go with the first option, option 1. Alright, work done is change in potential energy. That is the best way to calculate the work. Move to the next one, fine. Two resistance of the resistance R1 and R2. Okay, so here voltmeter is also not ideal. This voltmeter is also given to you as the resistance of 400. So RV is 400. That means 400 ohm. That means the equivalent of this 400 and 100 will be 400 into 100 by 500. That gives you 80 ohm. So now one is 100 and this is 80. That means equivalent of this circuit is 180, which gives you the current I, that is equals to 9 by 180, which is 1 by 20 ampere. We are interested to find out this potential across this voltmeter. So just to find out this potential across voltmeter, we can say this is 80 into I. So right, so this will be equals to I into R of this AB. Alright, this is the reading of the voltmeter. So that is 1 by 20 into 80 gives you 4 volt. 4 volt is your right answer. Go with the option 2. Alright. Okay, let's move to the next one. Okay, a brass rod is fixed rigidly at the two ends at 27 degrees centigrade. Okay, this session, the question paper is easy. In fact, on 24th, both the shifted are easy only. Okay, the hardest one is 22nd, second shift. Okay, a brass 23 is also little bit on the moderate side, higher side. But these two 24th session, both the papers are easy only. Now next question. A brass rod is rigid, fixed rigidly with the two ends. Okay, so there is a rod which is fixed at the two ends. Okay, suppose it will be at natural length at 27 degrees centigrade. Now, if the temperature is decreased, it tries to compress. So when it tries to compress, but it is bound to be on this length, that means there will be a stress develop. So stress develop. So if I say what is stress, then you will say stress should be equals to Y into strain. Stress will be in the form of tension, that is T by A, force upon area. It is equals to Y into strain, that is delta L by L. Now you know that thermal expansion, what is delta L? It is L alpha delta T. So here I can replace this as Y alpha delta T. That means the tension we can write down as Y into area into alpha delta T. Alright. This delta T, okay, let's represent this as tension. So let us say tension force, I will represent it by F, because otherwise 2T will be, we have to deal. So this is F, this is F. Okay. force of the tension. Now next, so here if you see the tension is given to you as T naught. So this F is given to you as T naught when this Y into A, when the temperature is changes from where to where? From 27 to minus 43 degrees centigrade. So when I solve it, it is minus T2 minus T1, it is minus 43 minus 27, right? And then they are saying at another temperature, its tension will be 1.4 T. So another temperature, let us say another temperature is minus T. So it is 1.4 T naught, that is equals to YA alpha. It is final temperature is minus T, initial is minus 27. All right. Okay, just divide it and solve it. So these two equations, I will simply divide it. What I am getting is 1.4, that is equals to T plus 27 divided by 70. So T is equals to 7 into 14 minus 27. This is 8 to 98 minus 27, which is 71. So 71 is the value of T, and temperature we have assumed T minus T. So that means what is the final temperature? Final temperature, that is equals to minus 71 degrees centigrade. All right. The temperature which they are asking is minus 71 degrees centigrade. Okay, let's move to the next one. Okay. Electric potential at a point is V is equals to AR cube plus B. Find the charge enclosed in the sphere of radius 1 meter centered at R equals to 0. Okay. So now there is a charge which is at the center of the sphere, and the potential at any point because of the central charge will be varies. So potential is given to you in terms of the radius R as AR cube plus B. All right, so with the help of this potential, if I find out the field is also radial here. So it is minus dV by dr. So this minus dV by dr is giving you 3AR square. Minus, that means this charge has to be negative because the field is into. Now apply the Gauss law. So if symmetrical field we are assuming here, then according to Gauss law, the closed integral of E dot ds, that will be equals to Q inside by epsilon naught gives you 3A R square, and ds will be 4 pi R square, that is equals to Q inside by epsilon naught. All right, and therefore this Q which is at the center is 12 into A minus 12 epsilon naught into A into R to the power 4. R is given to you 1, so R to the power 4 becomes 1 only. That's why the correct answer is option 3. We are going with the option 3. Minus 12 epsilon naught A. All right, let's move to the next one. Easy only. Okay, again LCR circuit. Very common questions, very frequent questions which you are familiar with is coming. So there is again power factor. Power factor, now you know power factor in AC LCR circuit will be nothing but R by Z. That means first I need to find out the impedance of this circuit, which is under root of R square plus XL minus XC whole square. That gives you as 60 square. That is your R, and this is 150 minus 70 whole square. So this is 80, this is 60, this is giving you 100 ohm. And that is why the power factor cos phi, that is equals to R is 60 and Z is 100, so it is 0.6. Absolutely simple calculation, simple concept. 0.6, option 3. All right, move to the next one. Okay, this is theoretical, and for this question, these questions, you know that this is fast moving electrons striking to the metal plate. Okay, this is the fast moving electron striking to the metal plate is the concept of X-ray, you know that. Okay, fast moving electron, when they strike to the metal, the rays will be radiated, called X-rays. So clearly your first option is goes with S. Okay. Then when we talk about infrared, so Wien's displacement law, you study that, okay, or at the normal temperature the heat is radiated in the form of, in the category of infrared rays. The lambda belongs to infrared. So that means infrared is what? Hot bodies or molecules, right? So we can say B is going with P. S into P. I think two options, S into P. Okay, so S into P is in the option 3 and 4. So let me check one more. So as you can see that radio waves and antenna, they are very familiar, they are linked. So definitely D is going with Q and C is going with R. So SP, RQ. SP, RQ will be the option 4. Okay. So theoretical, right? Next one, terminal velocity of the drop. Terminal velocity of the drop. So again, direct question, terminal velocity, you know that is depending on the radius of the spherical body. That's why to compare the two bodies, there are 64 bodies, 64 drops, 64 balls are combined to form a large drop of, let us say this is the radius R and this is the radius capital R. So many times you should remember the formula, otherwise by volume conservation also you can find out how to relate this capital R and small r. So this capital R will be n to the power 1 by 3 into small r. Alright, just by simple comparison of 4 by 3 pi capital R cube is equals to n times of 4 by 3 pi into small r cube. So this is 64 to the power 1 by 3 into r. That means this is 4 times of r. So radius will be 4 times of r, which means if I want to find out the terminal velocity final upon initial, it becomes capital R by small r whole square, which is 4. 4 means 16. So now I substitute this value of the terminal velocity before, which is 10. So 16 into 10 gives me 160. That means the terminal velocity of the bigger one will be 160 centimeter per second. All right, 160, that is option 1. So we are going with the option 1. Move to the next one. Light is incident at an angle so that the minimum deviation takes place. Minimum deviation takes place. Okay, so first you need to remember this properties of the prism, that if this is the angle of prism, then the minimum deviation occur when this I is equals to E. I is equals to this E, angle of incidence is equals to angle of emergence, which means R1 is equals to R2, which means A by 2, as R1 plus R2 is equals to A. So now, so we know that this is the minimum deviation condition. Now they are talking about that the internal reflection takes place on the second surface. So as you can see, that's the second surface. That means this ray will be striking at R2 and it is going for the TIR. If it is going for TIR, clearly this R2 becomes greater than theta c, greater than or equals to theta c. So I think this is memory based, so some information is missing. They are talking about the limiting condition. That means this R2 is equals to theta c. Okay, this R2 is equals to theta c. That means we can find out this theta c. What is theta c? Sine inverse of mu rare by mu denser. So this is sine inverse of, what is the rarer? N by 2, and what is the denser? N. That means this angle is 30 degree, sine inverse of 1 by 2. So R2 is 30 degree as well, R1 is also 30 degree. And that's why what is the angle of prism? A, that is 2R, means that will be equals to 60 degree. So this question answer should be 60 degree. Yes, we are going with the option 1. All right? All right? Okay. Next one. In the following configuration of the charges, find the net dipole moment of the system. Find out the net dipole moment of the system. So for this type of question, first you need to see what is the sum of the charge. Because when we are talking about dipole moment of the system, if the overall charge is 0, we can choose the pair of the dipoles individually. Like this, for example, here you see this is 2q, this is minus 4q, this is 2q. That means overall charge of the system is 0. That means they are forming the dipoles. So here if I take this 2q which is placed on 2a comma 0, and here it is minus 4q, so I split into 2q and 2q. So it can make one pair with this 2q as P1, and the another 2q part will be making the pair with another plus 2q which is placed at 0 comma minus 3a. That means here this system can be represented by two separate dipoles, P1 and P2, where P1 value will be, the distance between them is 2a. No, this point is minus 2a comma 0, so distance between them will be 4a. So it is q into d, so q value is 2q and d value is 4a. That means this P1 value will be 8qa. Whereas if you see this q2 value, P2 value, this P2 magnitude will be again 2q into this distance. Let us say this distance is r. So how to calculate this r? To calculate this r, this is 2a, this is 3a. This is 2a, this is 3a. So under root of 2a whole square plus 3a whole square, that will give you under root of 9 plus 4, 13. 13a square. That means it is root 13a, right? So root 13a. That is your P2. Now we have to combine this P1 and P2 at an angle theta. And mind it, this theta value also you remember. If I say what is this cos theta, then you will say, sir, base upon hypotenuse. So base is 2a and hypotenuse is r. Alright, which is root 13a. R, which is root 13a. So now I am combining P1 and P2 at an angle of theta. Simply vector sum. This is giving you P of the system as under root of P1 square plus P2 square plus 2P1 P2 cos theta. So this goes as P1 square, that is 64. QA is common in both, so I will take QA outside. 64 plus P2. So it is square 4 into 13. 4 into 13 is 26, 102. No. 1 minute. 26 into 2, right? 26 into 2. 13 into 4, right? So it is 52. Okay. Then this is 2 into P1, that is P1 is 8, P2 is root 2 root 13 into cos theta. So what about cos theta? Cos theta is equals to, that is 2a divided by r is root 13a. So this a cancels, this root 13 is also cancelled. This is giving you QA under root of 64 plus 52 plus 8, 64, right? So that means this is coming under root of 128 plus 52, which is 180. So QA root 180, that will be your answer. All right. We are going with the option A. Okay. So I did the full calculation. You can understand. Next. Okay, now this question. Density of water at 4 degrees 1000 and 20 degrees 998. So density is changing. Density is changing means volume is changing. So here the case is what? That this water sample is changing its volume. Volume change. Volume change because of density change. We have to find out 4 kg of water is heated from 4 to 20. Find out the change in internal energy. Okay, so change in internal energy we have to find out, which is nothing but Q minus W. You will say, sir, generally in case of water heating, we are considering Q only. But here if you see the values, they are very close. Why we are considering Q only? Because the work done is very, very less. The volume change is not very sufficiently large. So that means Q value is, W value is less only. That's why we are always consider Q is equals to MS delta T. But here, as you can observe, the values are very close. That means we have to consider both the terms separately, right? So Q is what? Q is MS into delta T. Now what is the mass given? Mass given as 4 kg. In SI, this specific heat capacity of water is 4200 into delta T is from 4 degree to 20. So 20 minus 4, that is 16. All right. So 16 means 64 into 4200. Now we will solve this. We are getting this as 268800 joules, right? As you can see that this is the option, and generally student made a mistake. They saw this option and they will mark it. But remember, this is only Q. And since the values are so close, means we are also going with the work. And for work, what we are doing, it is P delta V. P delta V, so pressure is the atmospheric pressure, that is 10 to the power 5. And for the mass, initial and final mass, I am taking M by final density minus M upon initial density. All right, that is 10 to the power 5. Mass is given to you 4. Final density becomes 998 and initial density is 1000. So easily we can solve this. This value is coming 0.8 joule. So you can see that in comparison to this value, this is quite a less value, right? This is quite a less value. So generally just substitute from this 268800 minus 0.8. That gives you the answer 268799.2 joules, which is option 1. All right, values are so close. That's why don't forget to write down the work done term also. Good question. Move to the next one. A particle is projected with a certain velocity. So okay. So again, projectile. In most of the session, projectile questions will be there. A projectile is projected with a certain speed at an angle of 45 degree with the horizontal at t equals to 2 seconds. It is at the highest point. That means t is equals to 2 seconds is the time of ascending, which means it is uy by g. So what is the vertical component of initial velocity? That will be equals to 20 meter per second. Okay, and then they are asking to find out this height. Find out this height. Height means vertical displacement. At the time 3 seconds, that means I can write down UIT minus half into G into T square. Alright, so this height will be UI, we got it as 20 into 3 seconds minus half into 10 into 3 square. This is 45, this is 60, 60 minus 45 gives you 15 meter. So 15 meter is the right answer for this question. 15 meter is the right answer for this question, option 3. Okay, move to the next one. Right, lot of dimensional formulas, okay. So quickly see that. Every day questions are coming from dimension formula, and 1 and 2 options are, once we check, we will get the answer. Okay, so we can save the time. Here also we are starting with the magnetic field intensity. We have so many formulas of magnetic field intensity B, but try to use the formula which is in which the terms are familiar. Just say for example, force is equals to BIL. So I will use F upon IL. F upon IL, that will be easy formula, because directly you know these terms as ML2T minus MLT minus 2. That is force divided by current is ampere and this is length. That's why it is coming as ML0 T minus 2 A minus 1. ML2 T M T minus 2 A minus 1. That means your first option is going with S. First option is going with S. So this second and third is cancelled. Now second, we have to, in two options it is there. So let's check the second one. Flux. Now flux is equals to B into A. So B you already got it into A. That means magnetic flux you can write down as ML2 T minus 2 into A minus 1. ML2 T minus 2 A minus 1, that is R. So second one is going with R, S and R. So clearly your option, first one. Easily you get this answer, first one, because here it is P. This is not correct. Alright, so just two terms are enough. Okay, you don't need to even check this. If you want, you can check them also and can get it. Okay, move to the next one. A cylindrical body of mass m. Okay, so question from the fluid and SHM. So a cylinder which is floating at the free surface and oscillating. Suppose if slightly pressed it and oscillating, then what is the time period we are getting for this? It is 2 pi under root of h by g, height of the cylinder, and this is rho b by rho w. Right, this is the standard formula for the time period. Now here, this rho b is not given to you, but mass is given to you, and so for mass of the cylinder we can write down it as rho b into volume. Volume I can write down as A into H, right? That means this rho b I can replace it by M by AH. Or you can say rho BH directly, you can replace it by M by A. That means this equation is converted into M by A. This term will be replaced by M by A into rho W into G. So that will be your answer for this question. So M by rho W means rho L. Okay. So which is the answer we are going with? Okay, the first option. 2 pi M upon rho L Ag. Okay, standard formula. Next one, the Zener diode of the breakdown voltage is 10 volt is connected to an external voltage of 15. So Zener diode, you know that it is like maintain the constant potential in the reverse biasing. This is 10 volt, so that means this is 5 volt clearly, as this is total is 15. So power of Zener diode is given to you. P is given to you across Zener diode, that is given to you. So it is Vz into I. That means this power is 0.4, that is equals to Vz is 10 into I. So this way you are getting the current in this circuit, which is 0.04 ampere. With the help of this current, I know the potential across R, that will be equals to I into R. So this is 5, I is 0.04 into R. We are getting this R as 125 ohms. Is it 500 by 4 is 125 ohm is your answer. Okay, so easy question. See, if you see the pattern, either they are giving the question from logic gate or Zener diode. Only in semiconductor, only these two concepts they are asking. And both are very simple. Okay. Okay, here. So this question by the options and diagram, it is looking horrible, but it is quite a simple question again. If you know the property, like what is the potential at the inside point of a spherical shell? It is KQ by capital R. Whereas what is the potential at outside point of the shell? It is KQ by small r. Okay, KQ by small r. These two formulas you should know. Now they are talking about different potentials. So I am just going to write down the potential of A. Now think about it. This shell is A. This shell is shell A. So for Q1 it is the surface only. For Q2 it is the internal point, and for Q3 also it is the internal point. So for Q1 so it is surface. That's why we are using KQ1 by surface of radius A. For Q2 it is the internal point, so KQ2 divided by, I have to take the radius of the Q2, as inside point, you have to take the radius r. So it is b, plus for q3 also, it is the internal point, a is the internal point, that's why we are taking the radius sc. This is your VA. Similarly, if I am writing down VB, so for VB, for Q1, this B point is outside. That's why KQ1 by R, small r is B. For this case, Q2, it is surface only. And for Q3, it is the internal point, that's why by C. And VC, when I'm talking about VC, for all the points, Q1, Q2, they are, C is the external point, that's why KQ1 plus Q2 by small r, which is C, and for Q3 it is C only because it is the surface. So we can write down this as KQ1 plus Q2 plus Q3 by C. Okay, that is the potential. Now you can check it. We are going with first one is ABC, second is BBC, and third is C. Okay, so it's option 4. All right. Okay, so moderate question. Next, an ideal gas is closed rigid container at 50 degrees centigrade and pressure 3.23 kilopascal. If the temperature is double, what is the new? Okay, so closed container means what is V? Constant. Okay, V is constant. Now V is constant means P by T is constant. So to find out the new pressure P2, we can say it is P1 into T2 by T1. Please don't confuse T and T1 and T2 are absolute temperature. So here is the twist. If I am talking about T1, then it is 50 degrees centigrade. And if I am talking about T2, it is double of that. Double of that means 100 degrees centigrade. So in Kelvin, it is not double. In Kelvin, this is going to be 273 plus 50, which is 323, and here it is going as 373, correct? So now I put these values. What is P1? P1 is 3.23, T2 is 373, and T1 is 323. In fact, the values itself is telling you that you are going at the right direction. So this is 100 times, this is 3.73. 3.73 kilopascal, which you can also write down as 3730 Pascal. 3730 Pascal is the right answer. You are going with the option 1. Okay, next one. Okay, again, when the pulley is not ideal, when the pulley is having mass, when the string and pulley is having friction and no sliding cases there, then we have to consider how to write down this acceleration by making the equation and solving them. Finally, what is this acceleration we are getting? m1 minus m2 into g upon m1 plus m2. Because generally this is the acceleration of Atwood machine, but since here disk is also rotating, so it is I by r square. Pulley is also rotating, that's why it is I by r square. I is the moment of inertia of the pulley. Now here acceleration is also given in terms of distance and time. So they are saying it is moving. If suppose they are moving, then they are saying that it is moving 81 centimeter in 9 seconds after release. So that means this is 81, which is half into A into 9. So it is 9 square. That means what is A? A becomes 81 cancel. It becomes 2 centimeter per second. Alright, 2 centimeter per second. So now I am going to substitute these values. So it is 2 by 100 meter per second square. Now substitute all the values and please put all the values in SI. So this is m1 minus m2 is 400 minus 350 into 10 to the power minus 3. They are in grams. into G is 10 divided by M1 plus M2, that is 0.4 plus 0.35 plus I by R square. R is 2 centimeter. Okay. So 2 centimeter means 0.02. Okay. So that means 2 means we can write down this as 4. Square of that is 4 into 10 to the power minus 4. This is equals to 2 by 100. Let me solve this. This is 0.75 plus I upon 4 into 10 to the power minus 4 is equals to rest of the term. So 1, 2, 3 into 3, this cancel. This is 50 by 2, this is 25. Alright. So I is equals to 25 minus 0.75 into 4 into 10 to the power minus 4. You can multiply this inside. This is 100 minus, this is 3. So 97 into 10 to the power minus 4. 97 into 10 to the power minus 4. We already convert all the unit in SI. That's why kg meter square. 97 into 10 to the power minus 4 kg meter square. Kg into meter square. Correct? Move to the next one. Okay. A bar magnet is kept such that it is making an angle of 30 degrees with the magnetic field. The torque acting is 0.016. Torque between magnet and the magnetic field when the magnet is placed in the magnetic field is given by M cross B, which is magnitude wise is MB sine theta. And theta is given to you half. That's why this is the value of MB by 2. As theta is 30 degree. As theta is given to you as 30 degree. So from here we are getting the value of MB as 2 into torque, which is given to you as 0.016, which is 0.032. This is the value of MB. Now they are saying that this magnet has to rotate from most stable condition, means theta equals to 0 degree, to the most unstable condition, that is theta equals to 180 degree. Right? We know that a stable and unstable condition. So to find out the work done, obviously it is going to be change in potential energy, which is final minus initial. Potential energy, how do you write down? Minus MB minus M dot B. MB cos theta. So it is final will be plus MB. Initial will be minus MB. So minus minus becomes plus. It becomes twice of MB. MB value you already know from here. Put this value and getting the final answer. 0.064 joules. 0.064 joules, that will be your final answer. Go with the option A. Okay. So dipole question with the magnet. Now still now all the questions, even the calculations are not very difficult. So I think this is the easiest session among all till now. Okay, next one. Greater is the mass of the nucleus, more will be its binding energy. Correct? Absolutely correct. Greater is the binding energy per nucleus. Mass. Greater is the mass of the nucleus, more is the binding energy. Yes. So mass is more, binding energy too. Binding energy means what? It is the required energy to disassemble all the nucleus separately, right? So that means this is absolutely correct. More is the mass, more is the binding energy. I am talking about binding energy, not binding energy per nucleon. Because even if the mass is more, but this is the nucleus is also more, that's why per nucleon that energy can be less also, because that is the deciding factor for the stability, right? That's why, for example, uranium is very heavy, but nucleons are also more, so binding energy per nucleon is less. That's why it is unstable, which is obviously they are explaining in the next. Nucleus with the binding energy per nucleon, if it is less, breaks into the nucleus with higher. Yeah. So binding energy per nucleon, if the less value is there, this is unstable. So it wants to move to the stable one, and stable one is what? Which is having higher binding energy per nucleon. So both the options are true. Both the options are true here. Okay, let's move to the next one. Light wave is incident from the medium of the refractive index 2, make an angle theta with the normal on to a medium of refractive index 2 root 3. 2 root 3. What should be the value of theta so that reflecting wave and they are perpendicular? So a Brewster angle, so you know that Brewster angle, okay, I think this is printing mistake, this is 2 root 3. So Brewster angle, because as you see that this is r, this is, so if angle is theta, otherwise Snell's law also you can apply, which is mu1 into sine theta is equals to mu2 into sine of 90 minus theta. As these two are perpendicular, by the diagram you itself can see that this is 90 minus theta, this is theta, that's why this is 90 minus theta. So angle I and this is angle R. And that is why tan theta is what? Mu2 by mu1, which is 2 root 3 by 2, which is root 3. And that is why theta value is coming as 60 degree. Okay, 60 degree. See, here the value is given 2 root 3 in the diagram will be. So 60 degree is the right answer. All right. Direct question again. Next. In the hydrogen-like ion, ratio of the speed of the electron in the 2 orbit. Okay, ratio of the speed. So its speed ratio is given to you. Right? Either you remember the Bose model that V is proportional to N by Z, Z by N, proportional to Z by N, and energy is proportional to Z square by N square. So that means if I have to find out the ratio of E1 by E2, it is simply V1 by V2 whole square, which is 9:4 is my answer. All right. Generally the expression will be all Ke square by R. So they are always half mv square. Simple way is half mv square is proportional to V square. So kinetic energy, potential energy expressions are same. That's why total energy expression wise I'm talking about. So dimensionally it will be square of this 9:4. Very easily you can do this question. Super simple. Next one. There is a compound microscope of the lenses having focal length 2 cm and 5 cm and tube length is 10 cm. Find magnifying power in the normal adjustment. If your answer is 5 to the power alpha, find alpha. Okay, so in the shift 1, 21st also this same question came. Direct formula. Normal adjustment means what is the magnification of the eyepiece? It is D by FE. And overall magnification of the compound microscope is given to you as L tube length by FO into D by FE. Alright, so simply substitution. Tube length is given to you as 10 centimeter, all are in centimeter. FO is given to you as 2, D is 25 centimeter and FE is 5. So 5 into 5, this 10 cancel, this is 25, which you can also write down as 5 to the power square. So if you have to compare this with 5 to the power alpha, the value of alpha will be nothing but 2. Okay, so find alpha. This is integer type. What is the value of alpha? That's 2. All right. Okay. So this is also one of the question. This is also one of the question which came, and I think because it is memory based, so information is not. But whatever is given, whatever values are given, if I try to solve it by this way, these all options are wrong. These all options are wrong. Okay. Okay. Let's see how to solve this question. Okay. So 8 kg, 6 kg and 4 kg. So first you get the normal. If I say this normal is N1, the normal between 6 kg and 8 kg is N2. Okay. The first normal I will say between 4 kg, 6 kg and then 6 kg and 8 kg and ground N3. So what is the value of N1? It becomes 40, means 40 Newton. What is the value of N2? It is 6 plus 4, that is 100. 10 kg corresponding to 100. And what is N3? N3 is corresponding to 18, so 180. mu is given to you half for each surface. Between each surface is half. Each surface means between ground also. So that means it gives me the maximum values between 1 and 2, that is 20 Newton. It gives me the maximum value between 6 and 8, that is equals to 50 Newton. And it is giving me the maximum value between ground and 8 kg as 90 Newton, mu n. Up next, what will be the maximum force which is acting on 8 kg so that it is moving with constant velocity? Fine. So first I will go with the free body diagram of 8 kg. Free body diagram of 8 kg, which is having the force F, which is moving with constant velocity. That means first you get the tendency of 8 kg. So I have to apply all the friction in the opposite direction along with the tension. And they are maximum also. So this F3 will be 90. This F2 will be 50. And this is moving with the constant velocity. That's why acceleration is 0. So here I am getting the first equation, that force is equals to 90 plus 50 plus t. Okay, this is the free body diagram of 8 kg. Now next one when we are moving to the free body diagram of 6 kg. This is interesting. This 6 kg is moving towards right. That means this F2 has to be opposite 100%. And this is also 50 Newton. No doubt about it. Also tension is there, that is T. And if this is moving with constant velocity, then 6 kg is also moving with the constant velocity, as there is a constraint. So acceleration of 6 kg is also 0. Problem is with this F1. Problem is with this F1. If I apply F1, it can be static, it can be kinetic, how to decide? So I have to look for 4 kg. अब see, are we getting any tendency of 4 kg? I'm not talking about they are starting from initial. Obviously, initially there will be some slipping and all. But if they are moving with the constant velocity, obviously acceleration of 6 kg is 0. Which means with respect to 6 kg, there will be no pseudo force on 4 kg. By tendency, you will decide with respect to the surface, and surface is 6 kg. So 6 kg is having acceleration 0. That means with respect to 6 kg, there is no tendency. There is no tendency of 4 kg. Both are moving with the constant velocity only. Right? Since its acceleration will be 0, that's why in the frame of 6 kg, I cannot apply any pseudo force on 4 kg, which is not giving me any tendency of motion. That means even if I am assuming F1, it becomes 0 only. Right? After all the settlement, finally when they start moving with the constant velocity, they are moving with the constant velocity, means 4 kg is not experiencing any acceleration. And that's why F1 is 0. So if I put F1 equals to 0, I am getting this T is equals to 50 Newton. And when you put this T equals to 50 Newton, your answer is coming out to be 190, which is not in the option. There might be, this is very good conceptual question. Okay. So might be there will be either missing of the data, or otherwise they did the conceptual mistake. But the right answer for this question, as per the diagram given and as per the data given, is going to be 190 Newton. Okay, 190 Newton. Okay, nice question. Move to the, generally 3 block systems are good only. So here, okay, that's it. So this is the end of the discussion. All 25 questions we discussed, and I put this particular test paper on the easy side. Okay, so already now 8 paper is already completed. Among all those papers, 22nd evening session and 23 both the sessions are on the difficult side, on the moderate side and difficult side. Rest of the paper is easy only. Okay, hope you did well. Okay, those who are going to appear on 28th, all the very best to them. Thank you.